This could have been a boarding house. Just a few steps from the hotel. The town really boomed once, and a lot of people used to come and go. But now, only the autumn wind does that through the hollow windows. And a few occasional visitors from another time. But what you find in Montana's ghost towns is a silent memorial to a once fabulous mining frontier. Of all the hopes that lured men across the Missouri to the Wild West, gold and silver shine the brightest.
The gold is there most anywhere. You can take it out rich with an iron crowbar. And where it is thick with a shovel and pick, you can pick it out in lumps as big as a brick. Then ho boys ho, to the gold mines we will go. There's plenty of gold in the West, I'm told, in the new El Dorado.
Mining brought the first settlements to Montana and helped hasten the day of statehood. Often, it was an unstable existence. Towns like this enjoyed a brief burst of hope and even prosperity, but when the gold and silver played out, the men moved on. The town died. Not all the mining camps became ghost towns. Not gold nor silver, but copper makes Butte, Montana alive and well. Long ago, copper proved every bit as valuable as gold and silver. Mining gave birth to Butte and makes Butte what it is today. One of those unforgettable character cities, full of fascinating contrasts and lots of personality. It's modern, friendly, and cosmopolitan, yet never quite out of touch with the past, with its mining heritage and the lifestyles and the hard work that gave Butte a robust past and a healthy perspective on the future. Butte grew up around a hill, like many other towns out west. But long ago, it got a nickname, the richest hill on earth. And over the years, it's had little difficulty living up to that legacy, with mineral resources of near legendary proportions. In 1864, around the creeks and gulches of this hill, men found gold. But that was placer mining, and when the surface gold began to disappear, so did most of the miners. Then, silver was discovered, and the nearly ghost camp of Butte revived and began to get a firm foothold on life. During the silver boom that followed, an Irish miner named Marcus Daly arrived to run some mines. From another Irishman, Daly bought the claim to a silver mine, the Anaconda. The year was 1880, and when Daly found a rich vein of copper in the Anaconda, he gambled on a hunch. Forget silver and start mining copper. Daly's instinct paid off. Back east, wires began going up to connect a couple of newfangled inventions, the electric light and the telephone. Overnight, copper ore, once considered a nuisance by the gold and silver miners, became the queen ore of Butte Hill. Daly had a start on his personal fortune, and Butte was on the brink of becoming the greatest copper camp on earth. By 1900, there were several hundred mines, shafts, and prospects working on the hill, supplying about a fourth of the world's copper needs. And most of it was high grade. ore to the grassroots, they said. The mines worked day and night shifts, and the primitive open roasting methods of the smelters on the edge of town filled the air with so much smoke and fumes that streetlights often had to be lit during the daytime. But nobody cared much in hell-roaring Butte. This was real prosperity. Miners came in from all over, the Irish, the Cousin Jacks, the mother-lode miners from California. Money was hard-earned and easy spent. More than one fortune was made and lost in the same day. No one worried, though. When the money ran out, well, there was always more of that waiting to be mined out of the richest hill on earth. A hill of legendary proportions indeed, because even now, long after those high-grade strikes of the bonanza days, the potential mineral reserves are still greater than the total tonnage extracted in all the years since the first prospector's shovel bit the earth of Butte Hill. Only now, the miner's shovel takes a 25-ton bite with every scoop. Yet from that 25 tons, barely 50 pounds of copper will finally result after costly and complex processing. That's how low-grade the copper yields have become. This is open pit mining, the Anaconda Company's Berkeley pit, the largest truck-operated pit in the country, over a mile in diameter and 1,200 feet deep, laying bare the workings of several former underground mines. Literally a man-made canyon requiring enormous resources in equipment and manpower, the kind of Herculean effort needed to keep America strong with copper from lower and lower grade ore. But shovels and trucks alone will not do the job. The operation demands an even more valuable commodity: men. Over 1,500 of them working round the clock. Skilled men who blast, load, haul, and dump about 250,000 tons of ore and waste every day. Imagine, if you will, the investment needed to extract ore from the pit. 133 massive trucks, literally diesel locomotives on rubber tires with capacities up to 200 tons. Sticker price on one of these babies is $500,000. Tires alone cost $11,000 each. But again, equipment alone will not do the job. Though dwarfed by the huge size of the trucks, the men who daily inspect, pamper, praise, and guide these behemoths are the key element. Without these men, the trucks are like so many sleeping giants, powerful but useless, waiting for the mechanics and drivers to breathe life into them. Operations like the Berkeley pit make Anaconda the largest single industrial employer in Montana, with a monthly payroll of many millions, plus an array of valuable benefits for the workers and their families. Anaconda spends scores of millions annually for its Montana payrolls and taxes and the purchase of supplies and services. The costs are high to produce 250 million pounds of Montana copper a year. Hauling in these giants is the main activity in the pit, but they're fed by a fleet of massive electric shovels and backed up by a variety of earth-moving and grading machinery. Service vehicles and facilities. And modern safety units.
Okay, 325, 323. Go ahead. Here comes the countdown. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, fire.
While the Berkeley pit now supplies most of the production, underground mining is still active. Anaconda operates 3 of the vein mines that honeycomb the earth below Butte. And the company is studying new large-scale techniques as the key to a successful underground mining program for the years ahead. Over 10,000 miles of shafts and tunnels have been excavated by several generations of miners in the search for high-grade ore. The deepest in operation descends over a mile beneath the surface. The men who work a mile deep and come home to dinner a mile high are specialists in vein mining, experienced and dedicated to the daily task of drilling, blasting, and mucking each round. The problems and costs of modern mining would astound the men who first worked the Butte Hill. Most of the old mining problems are still around, but added now are new ones, born of increased operating costs and the challenge of producing quality copper from lower grade ores. Swift, efficient hoist equipment is needed to safely transport miners to and from their work and to bring to the surface their daily average of 2,000 tons of ore. The problems of modern copper production crop up everywhere, but especially in the complex processing the ore must undergo, such as concentration, the first step in a long chain of production events. Ore from the pit must be pulverized. This requires powerful, large-capacity crushers. Then, together with the underground ore, the raw materials enter the Clyde E. Weed concentrator, one of the most scientifically advanced units of its type in the world. Here, the ore undergoes a further series of crushing operations, and the rumbling rod and ball mills never stop turning, constantly grinding the ore into fine powder. With the addition of water, the powder becomes slurry or pulp, to which chemical reagents are added. and the mixture is fed into the flotation section. Here, in a room so long it's hard to see the far end, 1,300 flotation cells are whirling, agitating and aerating the slurry to create foam. The copper minerals cling to the bubbles that are carried off as overflow, now assaying about 30% copper. Practically every step of the concentration process is operated and monitored from a central control room, a complex electronic nerve center.
Control.
The byword is quality control, and closed-circuit TV, X-ray assaying, and computer data complement the skillful judgment of the men who operate the concentrator. Out of each ton of ore that entered the concentrator, 52 pounds emerges as concentrate, to be loaded into tank cars of the company-owned railroad for shipment to the smelter in Anaconda, 26 miles away. Also riding the smelter-bound train is high-grade copper precipitate, obtained through the process of leaching, a method of recovering the small quantity of copper contained in the truckloads of discard hauled from the pit, material of such low-grade copper that recovery cannot be achieved by conventional concentration methods. This material is deposited in huge mounds called leach dumps. Water containing acid and pumped from the underground mines is filtered down through the leach dumps. The water emerging below the dumps has picked up copper minerals in solution and is channeled to the precipitation plant where it flows over mounds of shredded tin cans. The copper decomposes the cans, leaving a high-grade copper precipitate ready for the smelting process.
That's good.
The materials shipped from Butte arrive at the smelter for the next major step in the mine-to-consumer chain of events. The smelter, realm of hot, molten metal, blazing with fiery glare. Like the dawn of time when great thermal forces first spawned the Earth's mineral wealth. Smelting is like a form of sculpting because the process removes impurities just as a sculptor removes material to create. Through a series of copper blows, the sulfur and iron are oxidized and burned off, leaving nearly pure metallic copper. There's a lot of care and skill to this job. Through what appears like chaos, a form of ponderous precision emerges. Smelting produces molten copper 99% pure, which is cast into 460-pound anodes, large copper plates, to be further refined later by an electrolytic process. Smelting and casting require control of tremendous forces by skilled men concentrating on one objective: refinement of copper to rigid standards of quality. And Anaconda management is concerned about these men as they are about all personnel. Not just here, but in every phase of production, safety engineers oversee all operations. Final product of the smelter. Rows of blister copper anodes roll out on specially built railroad cars, headed for their next destination, the refinery at Great Falls, Montana. One last bit of refining takes place here at Great Falls. Final purification and recovery of gold and silver. In the electrolytic refinery, the copper anodes from the smelter are suspended in tanks, together with thin starter sheets of pure copper called cathodes. Current flowing through the electrolytic solution transfers pure copper from the anodes to the cathodes. When they're removed after about 2 weeks, the 7-pound cathodes are built up to 180-pound sheets of copper, now 99.9+% pure. The impurities left behind are recovered and treated to reclaim the gold, silver, and other elements. The high-purity copper cathodes are now ready for the furnace refinery, where they'll be melted, conditioned, and cast into commercial shapes. Each giant gas-fired furnace can treat more than 500,000 pounds of copper a day. It takes about 16 hours to melt the charge, after which the metal will have the most desirable chemical balance for the production of sound castings. A complex maze of costly and skillful production has finally freed this molten copper from its earthly bounds and brought it to the threshold of its usefulness. Here it is, pure and shining, shaping up to go to work along with its many alloys in every avenue of modern life. Its odyssey has just begun. For all its contributions to a better life, no mineral production can function without some effect on the environment. Anaconda is responsive to the problem, pioneering new ways to prove their conviction that progressive industry and quality environment are compatible. It takes courage and ingenuity and many dollars to solve pollution problems by completely changing proven production methods. But Anaconda has taken that giant step to bring into play an entirely new smelting technology, the arbiter process, invented by the company's own research department after 10 years of work. When the new plant is finished and in operation, it'll be the first air pollution-free copper reduction process in the world.
Hi.
Anaconda is one of the first industries to form its own special department just to deal with the company's use of land, air, and water resources. Day after day, skilled technicians run tests, scrutinize the environment, checking water and soil samples, and counting particle emission in the air. In the field, sensitive equipment measures and monitors virtually every operation of the company for its effect on the environment. But it's one thing to observe the effects and something else to act on them. That's the tough part of the job, the follow-up, solving pollution problems so they really work. That takes brain power and money, lots of it. Like more than 30 million at the smelter for environmental improvements, water-cooled converter furnace hoods, and a whole new flue system. And a high-efficiency plant to reclaim sulfuric acid from the sulfur dioxide gases produced in smelting. At the lime kiln, an ugly flow of lime dust once poured from the stack. Now a system of scrubbers removes all the pollutants, leaving only pure steam to escape. And it's taken more than $1 million to really start cleaning up the water used in copper production through a new system in Butte that has already won recognition as one of the best water pollution control systems in the nation. Silver Bow Creek, which carried industrial wastewater for a century, is now clearing up. In the old settling pond area near the smelter, the company has turned about 3,000 acres into a wildfowl preserve, managed by the Montana Fish and Game Department. In areas of extensive geological exploration in past years, Anaconda is now repairing the land, restoring access roads to normal contours, planting grasses and trees, and providing erosion controls, all in close cooperation with the U.S. Forest Service. These are just a few of Anaconda's efforts towards environmental protection. It's a big job for any industry. But when you live and work in Montana, you realize just how much is at stake. There are few places quite like it, with so much natural beauty. And you want to do all you can to keep it that way. The same kind of majestic wilderness was environment for the first mining pioneers of the West. But the word ecology was not in their vernacular. Few of them could sense in this rugged country the delicate balance between earth and air and water and man, any more than they could have envisioned the vast importance of the earth's mineral resources to the fabric of life in the generations ahead of them. The west of the mining frontier is gone, along with the pioneers who made it and the strike-it-rich sentiments of the bonanza days. We can't really say they despoiled the land, but their concern for the effects of mining was casual. When their mills stopped turning, the motion was picked up with even greater momentum by newer and better mining technology, by minerals industries responsible for providing the ingredients of a better way of life to a world eager for increased growth and progress on the one hand, but more and more alert to the consequences on the other. In the tradition of that responsibility, the copper industry continues to reach out, to innovate, and to expand its horizons of constructive service to mankind.